Dr. Mosen Tiwana once said, "The projects we have completed demonstrate what we know, and the future projects decide what we will learn." I am Niño Joshua G. Ortega.
I am Glenn G. Balighot.
I'm Seth Moises.
I'm Jeffrey Vasquez.
I'm Angelo Montesclaros.
I am Jeson M. Bergado, and we are the Group 1 of Central Mindanao University, Bachelor of Science in Civil Engineering.
The geotechnical approach of observing the behavior of the soil's properties is indeed a vital score in the field of engineering.
Problems related to this tend to emerge when this area will be neglected by engineers.
Thus, one must learn the facts and requirements pertaining to this topic, especially the standards set by the ruling entities and presiding bodies.
As the aspiring engineers in the future, it is our pleasure to present to you the things that we have learned all throughout this training.
By grouping and classifying the soil using its technical characteristics, an engineer could determine the capacity, behavior, and integrity of the soil in engineering. These technical characteristics are also considered to be the soil's properties, which are the subjects of the various tests. Some of the soil's properties are the moisture content, the specific gravity, the density or the relative gravity, the particle size, plasticity index, soil's compaction, permeability, bearing ratio, and the soil's consolidation. The American Society for Testing and Materials, as well as the American Association of State Highway and Transportation Officials, are the two main entities that serve as the front lines in setting and recommending standard requirements for the types of soil tests. U-Test, on the other hand, is a company that provides supports on design, implementation, production, and after-sales of calibrated materials and equipment. They also provide materials and apparatuses that are essential in doing the tests. The following are the types of soil tests in accordance with the standard requirements proposed and developed by ASTM and AASH2, and it is presented by the Central Mindanao University Bachelor of Science in Civil Engineering, Group 1B. First in line is the liquid and plastic limits determination, conforming to the ASTM D4318, which is Atterberg Limits Test, AASH2T89, Standard Method of Test for Determining the Liquid Limit of Soils, and AASH2T90, Standard Method of Test for Determining the Plastic Limit and Plasticity Index of Soils. The main materials are the Casa Grande and the sieve set, and these are the procedure on doing the liquid limit and the plastic limit, together with the moisture content, relative and specific gravity, and the grain size distribution. The plasticity index is essential on classifying the behavior of the soil. The next test will be discussed by Mr. Glenn Balighot. Glenn?
Okay, we are now on grain size analysis, conforming to the ASTM standards, ASTM D422, standard test method for particle size analysis of soils. So it has a lot of types, but we will be discussing two types here, which is the sieve analysis and the hydrometer analysis. So the difference between the two is that sieve analysis focuses more on coarser particles, while hydrometer analysis focuses more on finer particles. So we have here the main material for sieve analysis based on new test, or it is the sieve shaker with frequency and time adjustment, and it has a product code of UTG0323. The other one is that is the main material for hydrometer analysis, which is the hydrometer test set. Now for procedure of sieve analysis, we have here first is to collect the representative of soil sample. Then next is to break the soil sample into smaller particles or individual particles. Then determine the mass of the sample using accurate weighing device. Then prepare the stack of sieves from larger openings to smaller openings, and then pan at the bottom. Then pour the soil sample prepared in step 2. Then place the cover on the top of the stack of sieves. Run the sieves through a sieve shaker, which was mentioned earlier, for about 10 to 15 minutes. Then stop the sieve shaker and remove the stack of sieves. Then lastly, weigh the amount of soil retained on every sieve prepared. Now for the procedure of hydrometer analysis, first is to take the soil sample or from the bottom of the pan of sieve set, then place it into a beaker and add 125 ml of dispersing agent. Then stir the mixture until the soil thoroughly wet. Then let the soil soak for at least 10 minutes. Then while the soil is soaking, add 125 ml of dispersing agent into the control cylinder and fill it with distilled water to the mark. Then take the reading. Then next is to transfer the soil slurry into a mixer by adding more distilled water if necessary until the mixing cup is at least half full. Then mix the solution for a period of 10 minutes. 2 minutes I mean. Then next is to immediately transfer the soil slurry into the empty sedimentation cylinder and add distilled water up to the mark. Then next is to cover the open end of the cylinder, then turn the cylinder upside down and back up upright for a period of 1 minute. Then next is set the cylinder down and record the time. Remove the stopper from the cylinder. Then after elapsed time of 1 minute and 40 seconds, very slowly and carefully insert the hydrometer for the first reading. Then the hydrometer is removed slowly and placed into the back of the control cylinder. Very gently spin it, control cylinder to remove any particles that may have adhered. Then lastly, take the hydrometer readings after elapsed time of 2, 5, 8, 15, 20, 30, 60 minutes and 24 hours. The next test will be discussed by Mr. Seth Moises.
Thank you, Mr. Balighot. Hello everyone, I'm Seth V Moises and I'll be discussing two of the methods of soil compaction test. Soil compaction is necessary to increase the bearing capacity and stiffness of in situ or chemically modified soils. The first is field density test, ASTM D446-82 and ASH2 T9986. The main material used for this test is the sand replacement or the sand cone apparatus. It is used to determine the in situ density of the fine-grained compacted soil. You can read on your own the procedure for this test. Again, the field density test of soils is conducted in the field to know whether the specified compaction is achieved or not. The next type of compaction test is the standard Proctor test, ASTM D69891 or the ASH2 T9986. The main equipments used for this test are the mold and drummer. It is used to determine the relationship between the moisture content and density of compacted soil. You can also read on your own the procedure of this test. Overall, the standard Proctor test or Proctor compaction test establishes the variation of the unit weight of soil and degree of compaction with the moisture content. It also helps us find out the optimum moisture content for the highest practical density. And the next test will be discussed by Jeffrey Vasquez.
Thank you, Mr. Seth. Soil permeability test. Constant head permeability test, ASTM D2434. One important equipment of this test is the constant head permeability test, also known as the UTS 1315A from UTest. And these are used to study the behavior of soil, relatively coarse-grained soils. The first procedure is to measure the initial mass of pan along with the dried soil. Then remove the cup and upper chamber of the permeameter. Then place one porous stone on the inner support ring. Then mix the soil with sufficient quantity of distilled water. Then using a scoop, pour the prepared soil into the lower chamber. And using a tamping device, compact the layer of soil. Replace the upper chamber section and then place the compression spring on the porous stone. Then measure the sample length at 4 locations. After that, keep the pan with remaining soil in the drying oven. Adjust the level of funnel. Connect the flexible tube from tail of the funnel to the bottom outlet. Then place the tubing from top outlet. Open the bottom valve, and as soon as the water begins to flow out, close the control valve. Then close the bottom outlet. After that, open the bottom outlet. Allow adequate time for the flow pattern to stabilize. Then, measure the time it takes to fill a volume up to 1,000 milliliter using a graduated cylinder. Then measure the vertical distance h and repeat steps 17 and 18. Then remove the fan from the drying oven and measure the final mass of the pan along with the dried soil. Falling head permeability test. ASTM D2435. One important equipment of this test is the constant head filter tank, also known as the UTS 1309A from UTest. First is to prepare the undisturbed soil sample. So note down the sample number, then remove the protective cover, then place the sampling tube in the sample extraction frame, and then place the specimen centrally. Then the angular space shall be filled with cement slurry or wax. Then the drainage cup shall then be fixed over the top of the mold. Now the specimen is ready for the test. And for the preparation of disturbed soil sample, take 2.5 kg of mixed air-dried or oven-dried material. Then the initial moisture shall be determined and add quantity of water. Then mix the soil thoroughly. Weigh the empty permeameter mold, then clamp it. After that, compact the soil, and then remove the excess soil. Then find the weight of the mold with sample. Then place the mold with the sample in the permeameter. Here is the common procedure of both soil samples. The next test will be discussed by Mr. Angelo Montesclaros.
In the triaxial test, it consists of 3 tests: the unconsolidated undrained triaxial test or UU test, the consolidated drain test CD test, and the consolidated undrained test CU test. Given that you have followed the procedures from step 1 to 24, you just have to make sure that your sample is already saturated or as close to saturation. In this first test, the UU test, unconsolidated undrained triaxial test, the drainage valve are all closed, both in the consolidation and shearing stage or tests, and it is brought to failure by increasing the vertical stress by applying a constant rate of axial strain. Since saturation and consolidation do not exist in this test, the original structure and water content of the specimen is untouched. And for the consolidated drain test, you just repeat all the steps since it's all similar from step 1 to 24. During this test, the drainage valve is open both during the consolidation and shear test. Any excess pore pressure is allowed to dissipate so that there are no excess pore pressures. So it will become an effective stress test. So make sure that shearing is done slowly to avoid generation of pore pressure. The major principal stress at failure is also the effective stress. For the consolidated undrained test, repeat everything from steps 1 to 24. However, the main difference is the drainage valve is open during the confining, while the confining stress is applied until the specimen is consolidated and all the pore pressure is dissipated. But it is closed during the shear phase to create an undrained condition. Then the excess pore pressure is then measured during the shear test. Vertical stress is increased until failure, noting also pore pressure. The main equipment for UU, CU, and CD tests, the triaxial chamber. The last soil test will be explained by Mr. Bergado.
Thank you for that report, Mr. Montesclaros. And now, we will discuss about California bearing ratio test under ASTM D1883-16 and ASTM D4429-09. CBR test is used to determine the material strength for pavement design. So, kadalasan sa mga kalsada, sa mga roads, para malaman kung ano yung dapat na thickness ng subgrade or yung lupa. The main material or equipment for CBR test is the automatic CBR test machine. And then, for the procedure, number 1, the diameter and depth of mold is determined and the weight of the empty mold with base. Weigh about 7.5 kg of soil spread onto a wide steel container and crush any big lumps of soil before mixing with water. And then mix the soil with a certain amount of water needed. Insert the first portion of soil into the mold until the layer occupies about 1.5 of the height of the mold. Then every layer, that is 5 layers, and every layer must be compacted with 4.5 kg rammer by applying 62 blows evenly distributed. Then repeat the same procedure using the 4 portions of soil in turn. And then after that, remove the collar and trim the soil flush with the top of the mold. And then clean the mold. And after completing the penetration test, take a sample immediately below penetrated surface and determine the moisture content of each sample. Then subsequently carry out the test on the base by repeating the same procedure. And then lastly, oven-dried soil overnight before dry sample weight of measure. For the next test, which is direct shear test under ASTM D3080. So direct shear test is a geotechnical engineering experiment to measure the shear strength of the soil when it is subjected to a specific load. So ginagamit ito para malaman yung shear resistance or strength ng soil kung kaya ba niyang i-handle ang specific load. And for the main material for direct shear test is the direct shear test set. And then for the procedure, collect the soil sample that hasn't been remolded or hasn't been disturbed. A sampler and a rammer should be used to collect the sample. Then the sampler's inner dimension should be 60 mm by 60 mm in plan, which are the same as the shear box inner dimensions. Then weigh the weight of the soil sample and record its weight. Then set up the shear box. So sa pag-set up ng shear box, just follow the procedure. And then sa huling pag-set up ng shear box is place the loading yoke on the loading pad and carefully lift the hanger onto the top of the loading yoke. Set the probing ring to 0 and set up the monitor. Make sure that the machine is properly set up. Check if the horizontal axis of the machine is labeled. So may bubble na nakalagay dun. Start the experiment and wait until the machine will stop automatically. Then record the data. Then just repeat all steps by using different compressive stress.
Guided by the Hytec Power Incorporated and the Central Mindanao University, particularly the Civil Engineering Department, with the help of Electude and U-Test, we, the Group 1, is done with our presentation.